Page 2, 2010-2011 written round competition 2. What is the distance between the points 3, 8 and 4, -10 on a coordinate graph? Express your answer in simplest radical form. So there is a formula for it. It is the square root of x2 minus x1 plus y2 minus y1. But essentially, if you don't remember that, don't worry about it. This is a Pythagorean theorem problem. So let's call this point 3, 8. And let's call this point 4, -10. So what I'm going to do is I'm going to just make a triangle out of it, right? So what is the distance here? Well, the distance is from 3 to 4, which is 1. Distance from here to here is going to be 8 going down plus the -10, so that's 18, right? So then what we have to do is we have to find the hypotenuse, and we use the Pythagorean theorem, which is a squared plus b squared is equal to c squared. So we have 1 squared plus 18 squared is equal to c squared. So 18 squared is 8 times 8 is 4. I wish I knew this off the top of my head, but I don't, which is somewhat embarrassing. There we go, 324. And then we're going to add to that 1, which is 325, and we have to take the square root of it. So we break it apart, so it's square root of 25 times the square root of 13. Square root of 25 is 5 times square root of 13. So that's how you do it. I normally just advocate this because it's easier than having to remember a formula in isolation. Make a triangle out of it, find the hypotenuse using the Pythagorean theorem. Okay. Bag contains 6 red, 5 blue, 4 yellow, 3 green. A ball is drawn at random from a bag. What is the probability the ball is blue or green? All right, so there. 6 plus 4 is 10, plus 5 is 18, plus 3 is, sorry, it's 15 plus 3 is 18. So we have 18 total balls in the bag, and then I have blue or green. I have 5 blues and 3 greens, so that's 8. So then I have to reduce this to 2 goes into both. So 4 over 9. So then 13. How many groups of 4 students can be formed from a class of 15? This is a combination because order doesn't matter. I can have Anya, Campbell, Kirk, and Aaron, or Aaron, Kirk, Anya, and Campbell. The order doesn't matter. That's the same grouping of people, right? Right. Okay. So that's a combination of 15 and 4. And we remember it's n factorial over n minus r factorial times r factorial. So we have 15 factorial, which is 15 times 14 times 13 times 12 times 11 factorial over n minus r. So 15 minus 14 is 11 factorial. And notice how I'm stacking this. And then 4 factorial is 4 times 3. Come on, there you go. Come on. Sorry. 3. My pens are really unhappily working right now. So 11 factorial divided 11 factorial is just 1, so it cancels out. 4 times 3 is 12. 12 divided by 12 is 1. And then we still have the 2 left over from the factorial. We 3, 4, 3, and the 2. So that's 7. And then that cancels out, so we have 15 times 7 times 13. So you just multiply these together. 15 times 7. So it's 5, 3, 10. And then I have to multiply that. So then I have to multiply it by 13. So that's 100 plus 5. So 13 times 100 is 1300. 5 times 13 is 5. Carry the 1, 6. So it's 3165. And there you have it. That's how many different teams you can come up with. Ta-da! All right, 14. Sorry about that long-winded one. Juan's car gets 28 miles per gallon. He drives 308 miles. If gas costs $2.72, how much will Juan have to pay for gas? I remember this one too. This one's another long one. Again, I would save this for the end. Don't do this first. When you see how long the calculations are going to be, do this one last, okay? So, I'm going to do it now. So Juan's car gets 28 miles per gallon, so the first thing we have to do is we have to figure out how many gallons he used and then multiply that times the cost of gas. So I'm going to use a calculator here just to go quickly. So 308 divided by 28 is 11. Convenient. And then we multiply it by 2.72. And that's $29.92. I mean, it's just a plug and chug problem. Write 1,575 as a product of primes. Use exponents when possible. No kidding. So essentially this is prime factorization. So we have, well, I know 25 goes into this, right? And I know 25 is 5 times 5. And then 1,575 divided by 25, 63. Obviously, you'd have to do that by hand. I'm just trying to expedite things. This is 7 times 3 times 3, better known as 9. So we have 2 3's, so it's 3 squared. Now, in prime factorization, you are expected to use the multiplication x, and it has to be in ascending orders of the base. So then we have 5 squared times 7. And there we have it. All right, number 16. A hand consists of 4 cards that are dealt from 8 cards numbered 1 through 8. How many different hands are possible? All right, so the question is this a combination or permutation? So 4 cards are dealt 8 cards that are numbered 1 through 8. So each card is different. But the question is a 1, 2, 3, 4 different than a 4, 3, 2, 1? In this case, the answer is no, because we're not adding these numbers together. They're just pieces. They're parts of a deck. So I believe this is a combination. So we have combination 8, 4. So we have 8, oh, right over here. 8 times 7 times 6 times 5 times 4 times 3 times 2. And then we have 4 factorial and 4 factorial because it's n minus r factorial, r factorial. So 4, 3, 2. And then 4, 3, 2. 3, 2, so that cancels. And then we have our 4, so that's 2. So 35 times 2 is 70, and that's the correct answer, 70. What is the probability of drawing a number divisible by 3 in a deck, in a regular deck of 52 line cards. So what is the probability of drawing a number that's divisible by 3? So we have 52 cards, right? And what is divisible by 3? Well, the 3, the 6, and the 9. And there are 4 of each, right? So we have a total of 12 cards that are divisible by 3. Divided by 52. So what goes into 52? I think 4 goes into both of them. So we have 3 over 1, 1, 3. So it's 3/13ths of a chance. And that's it. All right. 18. The base of a triangle is 3 centimeters longer. All right. So here we go. The base is 3 longer, 2 times x. Here's your x. And so the height, the area is that. So area of a triangle is base times height. So we have the height times the base. And it's divided by 2 is equal to 115. And so then I multiply both sides by 2. So we have x times 2x plus 3 is equal to 230. So multiply this out. So I have 2x plus 3 minus 230 is equal to 0, because this is a quadratic that I'm being asked to solve. So here's the trick. With a number here, it makes it far more complicated. So I know there's going to be an x. I know there's going to be an x here. This is a negative, so I'm going to have one positive and one negative. So here's the thing. What goes into 230? Well, 10 and 23 does. And you're going to tell me 10 and 23 does not have a middle term of 3x. But here's the thing. Since we have this 2, we're multiplying this 2 times one of the 2 factors of this term right here. And I know that 2 times 10 is 20. And 20 is 3 less than 23. I think we have it. So the 2 has to be across from the 10. And the 10 has to be positive because, no, the 10 has to be negative because 2 times 10 is 20. It has to be negative 20 because we have our 23 here. So there we have it. So we've factored it correctly, and it's equal to 0. So this is going to be an ugly fraction, and it's going to be negative. And we know that a side length can't be negative. X here is going to be equal to positive 10. So that means the x value of the triangle is 10. Therefore, this is 10. And there you go. It's complicated, but you guys can do it, especially you 8th graders. All right, number 19. Target buys shoes for $15 and sells them for 24. What is the percentage increase? So we have the increase. My goodness gracious. The increase is $9, right? 9 over 15. So what percent is 9 over 15? Well, you can reduce it, so that's 3 over 5, which is 60%. Pretty pretty. All right. And then how many 2-digit prime numbers less than 50 exist, such that the positive difference of their digits is odd? All right. How many 2-digit prime numbers less than 50 exist, such that the positive difference of the 2 digits? Okay. So let's take a look at some prime numbers. We have 2-digit prime numbers. We have 11, but that doesn't work because their sum is 0. 13, the positive difference of that is 2, right? Yep. And the difference is odd, so that works. The next one is 17. 17, that works, doesn't it? But that's not odd. No, the difference here is not. It's 2. That doesn't work either. So then, that means an odd and an odd, and they're all going to be odds from here, isn't going to work. So we only have to look at the 20s and the 40s. So we have 23, and that gives me an odd product, so that's 1. 25, 27, no, 29, 29. So none of the 30s will work, so we're on to the 40s. 41, 43 is prime, and 47. So 1, 2, 3, 4, 5. So the trick here is to know 2 negatives subtracted will end up with an even answer. So it has to be an even and an odd, and the last digit has to be odd. So therefore the first digit must be even. 5. All right. How many 3-digit numbers can be made using the digits 1, 5, 9, 6, 4? How many 3-digit numbers can be made using? Okay. Order is important in this one because 1, 5, 9 is different than 9, 5, 1. This is a permutation. So we have 1, 2, 3. We have 6 numbers and we have 3. So it's 6 fact. Oh my goodness, it's driving me crazy. So we have 6, 5, 4, 3, 2, 1 over 3 factorial, 3, 2, 1, because it's n factorial over n minus r factorial, and that's it. There's nothing else. So then we have 6 times 5, which is 30, times 4, which is 120. And that's the correct answer, 120. So again, the permutations is n, p, r, n factorial, n minus r factorial. That's the permutation one. And that's it. So we'll move on to the individual round next.